In this example, let's consider a cylindrical body, and the state of stress in the body is given to us as sigma z theta is equal to alpha little r over big R. And alpha is a parameter. We're told it's 10 ksi, so thousands of pounds per square inch. Capital R is 2 inches, so the diameter of our circular bar here is 4 inches. And the question is to find the net moment acting on this cross-section shown here in red. So if I look down at the cross-section, it looks like this. I have the x-coordinate and the y-coordinate like that, and then the z-coordinate is coming out of this plane here. And I'd like to find the net moment acting on this surface right here. So first let me consider a little bit of area acting on the surface. Acting on that little bit of area, if we call that area dA, is going to be a force which is sigma z theta, so that's force per unit area, times the area, which is dA. So that's the force acting on that bit of area, and it's pointing in the theta direction. So, and it has a lever arm to the origin, so we'll calculate the net moment about the origin of r. So r is just the radial distance out, and so the vector that goes from the origin out to this little bit of area is exactly orthogonal to this bit of force here, sigma z theta dA. So r times that force is going to give me a moment, and now I can add up the moment from all the bits of area acting on this, across this cross section. So if I add them all up, then I'm going to end up with, say, more lever arms, but there will always be r, and I'm going to end up with the moment about the z-axis. So, and the final expression then is the moment is equal to the integral over the cross-sectional area of r sigma z theta dA. I can go ahead and write out that integral. It's a double integral, 0 to 2 pi for theta and 0 to capital R for r. Plugging in for sigma z theta and multiplying through, I get alpha r squared over capital R, and then dA is the polar area, which is r dr d theta. So this is a straightforward integral. I can compute it. It's pi capital R cubed alpha over 2, and if I plug in my numbers, I have a final answer of 126 kip inches for the total moment about the z-axis acting on this section cut.